Space Center, and joining me on the line today are Ken Bowersox, Associate Administrator for NASA's Space Operations Mission Directorate, Steve Stitch, Manager for NASA's Commercial Crew Program, and Dana Weigel, Manager of NASA's International Space Station Program. We're going to give our participants some opportunities to provide opening remarks today before getting into the question and answer portion of our session. We've recently had some technical difficulties on some of our conference calls, so our conference line will be moderated by the call moderator during the Q&A portion today. We already see some of you in the queue, but a reminder, if you have a question, press star 1 to raise your hand and press star 2 to lower it if you hear your question answered. We're going to get started with those opening remarks, and so I will turn it over to Ken.
Hey, hello everybody. Thanks for joining us today. As always, we appreciate your interest and the time that you're spending with us. I know everybody's eager to hear about what's going on orbit. We've got Steve Stitch and Dana Weigel from the ISS program and Commercial Crew Program to help you with any information you might need about what we've got going on in our different program efforts up in low Earth orbit. We like to share information as often as we can. Our tendency is to wait until we've got really clear information to provide you on decisions that we're making. In the current situation we have on orbit, especially with Starliner, that information has been slower to develop. It's kind of interesting. Our decision-making process at NASA can run really fast, or it can take a while. What you find is that the speed of the decision can vary with the clarity of the information you're working with, the amount of uncertainty in the problem, the time that you have available, and the number of options that you have to deal with issues. If you talk Starliner in particular, we're in a kind of a new situation here in that we've got multiple options. We don't just have to bring a crew back on Starliner, for example. We could bring them back on another vehicle. That's something that we're going to have to deal with in the future. We could find ourselves in a situation where we need to bring a Dragon crew or a Soyuz crew back on a Starliner. That's why we want multiple vehicles, is so that we have that option, but it gives us a lot more to talk about in our decision-making process. In the case that we have with the Starliner crew flight test, the option to either bring the crew home on the Starliner or to bring the crew home on another vehicle, we could take either path, and reasonable people could pick either path depending on where their view is on our position in the uncertainty bound that we have for the data that we've got on the thruster system, on the propulsion system. So moving forward, what we're trying to do is reduce that uncertainty, see if we can drive some more consensus amongst our team. At the same time, getting more serious about evaluating our other options. It's been really great to watch our team working, our Boeing team, our NASA team, the way people are speaking up, the way we're hearing different voices, different thoughts on how critical different factors are in the decision. I think it's been very healthy. I have to admit that sometimes when we get disagreement, it's not fun. It can be painful having those discussions, but it's what makes us a good organization, and it's what will get us to a good decision as we approach that point here in the future. And I don't think we're too far away from making that call. We know that at some point we need to bring Butch and Sonny home. While they're up there, we have extra crews, we have extra hands. They can do a lot more work, but they're also using up more consumables, more supplies. So we have to maintain that balance, and at some point we need to bring those folks home and get back to a normal crew size on the ISS. But again, I just want to say how proud I am of our team and the way they have these open discussions, open conversations, and the way we're working through the data gathering and analysis process. Today, Steve will talk to you a little bit more about what we have going on in the commercial crew area, and Dana will share more information about what we've had occurring on the station side and the Cygnus that we just brought aboard the other day. Now I'd like to turn it over to Steve so he can share more details from his point of view. Steve?
Yeah, thanks, Ken, and thanks to all of you for dialing in today and all your interest in the Commercial Crew Program and human spaceflight. I'd like to start off by giving everybody an update on where we are with respect to the analysis, in particular on the thrusters and the flight rationale for the return of Starliner. And then I'll talk a little bit more about the manifest changes we've made and what we've done to give ourselves some flexibility in the near term relative to all the options that we're looking at. So if we start with Starliner, last time we talked a lot about the testing results at White Sands. We had completed the thruster testing, which was essentially two uphill profiles trying to get to the temps that we saw on this particular thruster, and then we really have done 5 downhill profiles with that particular thruster. We were able to replicate degradation in the thruster during that testing, and we saw that continually on the downhill side with the thrust levels degrading over time, which seems to mimic what we're seeing in flight to some extent during those downhill profiles. As we talked about during that testing, we gained insight into what we think one of the contributing factors are for that thrust degradation, and that would be this Teflon seal on the oxidizer line poppet. Now, this poppet's really small. It's about, if you hold up your little pinky finger, it's about the size of that, a little bit smaller even than your pinky finger, so it's a small poppet. But what we saw during that testing is the swelling of that Teflon seal. It kind of extruded a little bit, and what happens with that seal is it blocks the flow into the thruster itself, down into the combustion chamber. So we know that's happening. We know we can get vaporization when it gets hot in that line, bringing propellant into the thruster, and also when that poppet is blocked by the Teflon seal, we see some cavitation. In other words, unsteady flow across that poppet. We have some animation that we hope to be able to release soon to you so you can see what this is like. Boeing has been doing a lot of work on that animation, and hopefully we can have them share that soon so you can get a better idea of that mechanism as well. We also have this same theory that has some vaporization of the propellant, right, and it drops the thrust. So there's really two key things that we think is happening. One, when the thruster gets really hot, the propellant can vaporize. That's where we saw the really low thrust readings on docking day, and then as the poppet swells, we can get some blockage there based on what we learned at White Sands. What we're trying to do now is sort of understand what all that data means to us from the White Sands testing, and then what it means to the thrusters on orbit. We did do a hot fire while we're docked to the International Space Station on Saturday, July 11th. We wanted to understand the performance of all the thrusters across the vehicle, so we hot fired all 27 thrusters. We did not hot fire one thruster in the bottom doghouse. We call it the B1A3 thruster. That one had really low thrust before during the when we were docking back on July 6th, and so we did not, or June 6th, and we did not hot fire that thruster. The interesting thing when we hot fired the thrusters is all the thrusters now across the whole vehicle are essentially at nominal thrust level. So, for example, the one that we were really saw the most degradation in, T2A2, was at about 80% before the hot fire, and now it's about 98%. So somehow, if the poppet is the theory of what's causing the thrust degradation, the blockage in that ox flow, somehow that piece of Teflon must have contracted and is now not blocking the flow like it was, and so we have a nominal flow essentially into that thruster and nominal thrust. What we're really trying to do now, that gives us a lot of confidence in the thrusters, but we can't, totally prove with certainty what we're seeing on orbit is exactly what's been replicated on the ground. We're trying to understand a little bit more about the conditions that cause the thruster fail-offs. It's not always at the same temperature. It's not always at the same number of pulses, and so we're trying to understand that. We are doing modeling on the ground to try to understand how this Teflon could extrude, what the forces are on that Teflon, and then trying to understand how it could contract in how it could contract over time. People really want to understand the physics of what's going on relative to the physics of the Teflon, what's causing it to heat up, what's causing it to contract, and that's really what the team is off trying to understand, and then look ahead toward the downhill phase and the heating on the downhill phase, and seeing if we can model that on the downhill phase and ensure we have good thrusters. Again, as I've talked, we have really good knowledge of what the downhill is, but how does that really help us out? So, in combination with that, we have tried to buy ourselves a little bit of time to work various options for return. And so recently this week at the Program Control Board, just yesterday, we approved moving the Crew 9 mission to no earlier than September 24th. We took that to the Program Control Board, and it was approved, and we immediately put out a blog to make sure that everybody knew that we had made that decision. We appreciate your patience over the last few weeks. It took a little time to work with SpaceX on that movement of that flight, and also with the ISS program, because it's a very complicated manifest. In addition, we moved the Crew 9 mission off of Pad 39A onto Pad 40 to deconflict with the pad preparations in September for NASA's Europa Clipper mission, which is flying off 39A with an October 10th launch date. So we've been working the certification of Pad 40 for a long time. We've always wanted to have a backup pad for these kinds of scenarios, and so that work has been underway for some time, and we think we can get that certification completed in time for a September 24th launch of Crew 9. We will let SpaceX use our first stage booster. They'll go fly a Starlink flight ahead of our flight to get a little shakedown of that booster. It had some moisture intrusion, and we want to go ahead and get that booster flown. And so there's a win-win there with flying our booster on a Starlink flight before our crewed flight. Essentially what we are doing is we're taking the SpaceX 31 slot that was out there in the manifest, and we'll let Dana talk more about that. As we've said before, our prime option is to return Butch and Sunny on Starliner. However, we have done the requisite planning to make sure we have other options open. And so we have been working with SpaceX to ensure that they're ready to respond on Crew 9 for a contingency of returning Butch and Sunny on Crew 9 if we need that. We have set up the Dragon for Crew 9 to have flexibility to have only 2 passengers fly up on that flight, and then we could return 4 crew members in the February 2025 timeframe, and Butch and Sunny would remain on station and become part of that increment and return home with them on Crew 9. Now, we haven't approved this plan. In other words, we've done all the work to make sure this plan is there. We have the suits identified to fly up on Crew 9. We have the seats set up so that we can fly a multiple complement of people, but we have not turned that on formally as that's the path that we're going to go down. But we wanted to make sure we had all that flexibility in place. We'll fly up the supplies needed on that Crew 9 flight, including any suits needed for Butch and Sunny. We've done previous work with that for other contingencies. And we'll have the right foam inserts to work on all the seats for the various crew members. We've had a lot of discussion and questions about task orders recently, and I would say, we've done a lot of work in Commercial Crew to prepare for multiple contingency options. The first one is, and we want to be open and transparent about those options, the first one is to have an option in Dragon on the cargo pallet to fly 1 crew member, a total of 5 crew members down in a contingency only. And so we had a task order in place to go do that work, and that's out there. And so that work has been completed, and we now have modified the capability to not use a seat liner, but also use the phone. On Crew 9, we now have the capability to fly 2 crew members up and have ballast in the seats for that, and then return a total of 4 crew members with the right seats. We actually put out a task order with SpaceX to do that work, and that task order is out there in place, and SpaceX has completed an initial part of that work, and then there's a final part of the work to configure the vehicle for the 2 crew option and complete training for the crew for that option. And then finally, there's one more task order that we have worked on in the event that we have to undock Starliner first in an uncrewed configuration. We have a task order in place to allow up to 3 crew members on the cargo pallet using a foam configuration in the Crew 8 Dragon. So we've done a lot of contingency work and a lot of contingency planning for a lot of scenarios, but we think now we would have the whole waterfront covered. As I said, we haven't really implemented planning for the mission for these things, but we have all these items in place to keep all the options on the table. I want to clarify a couple things relative to the uncrewed Starliner configuration relative to undock. That Starliner has the capability to undock in an uncrewed configuration. However, the mission data loads for this flight, the flight software we have on board today, are set up for a crewed undock. And what that means is, in close to station, for docking and undocking, the failure response matrix in the software downloads to a crew manual capability for any breakouts. In order to do the uncrewed version, we'll have to go in and change these mission data loads and verify those through the Boeing Integrated Hardware Software Test Facility before we go fly that. There would be also additional training that the Boeing flight control team would have to undergo, and some work to go lay out all that work. So the software on Dragon is fine, or on Starliner is fine. It can actually handle the capability to do an uncrewed undock. It's exactly what we did on OFT2. We just have to go configure some software parameters, not change the software to go do so. I think we've talked about all the scenarios. I want to reiterate we haven't made a decision yet relative to return Butch and Sunny on Starliner or on Dragon on Crew 9. We appreciate your patience. It's been a very complicated time frame. There's been a lot of work going on across all different entities relative to this work. I want to say how proud I am of the NASA, the Boeing, and the SpaceX team for having their head down and doing all the requisite work to make all these options viable for the program. We are in a unique position in Commercial Crew where we have all these options now, and we will use the right option at the right time. And so the decision point is ahead of us, and I will turn it over to Dana Weigel.
All right, thank you, Steve. Good afternoon. Thank you very much for joining us today. You know, as Ken noted, we take the accurate and timely sharing of information very seriously, and so I hope I can share with you the most up-to-date and relevant information on the ISS side related to onboard activities. On board right now we have 6 spacecraft attached to station with the arrival of Northrop Grumman 21 Cygnus mission recently. We have a number of spacecraft arrivals and departures that are upcoming in the next few weeks. We have a departure of the Progress 87P on August 12th. We've got the arrival of the next Progress, which is 89P, on August 17th. Next arrival of the Soyuz 72S will be on September 11th. That'll be carrying NASA astronaut Don Pettit. And then after a handover period, the 71S Soyuz will depart on September 23rd with Tracy Dyson. One of the things in this scenario that Steve laid out for you in terms of vehicle sequencing, given that we have only 2 docking ports on board, and right now we've got Crew 8 vehicle on board and we've got Starliner on board. Before we launch Crew 9, we will need to undock the Starliner first, so that's first in the sequence of events. So after Starliner undocks, we'll launch Crew 9, and as Steve said, that's now moved to late September. Of course, the crew will do a handover, and then Crew 8 would leave about a week later. And around the corner after that, we will launch our SpaceX 31 Dragon cargo resupply mission. I know in previous briefings I've mentioned that it's been helpful to have the extra set of hands on board with Butch and Sunny. They've been continuing to help us out quite a bit with maintenance and getting extra science done on board, which we really appreciate. I do want to highlight a few other special topic, a few other things for you. For Northrop Grumman, for that mission, that carried over 8,200 pounds of critical resupply, spares, crew supplies, and science.
So the crew right now is spending their time unloading it. It's pretty busy the first couple days that a vehicle comes up. There's a lot of critical science and research and a lot of things that they need to get to in the first few days, so that's what they're focused on. I do want to commend our Northrop Grumman and our NASA teams for the work they did addressing an engine burn execution issue that was encountered uphill. Shortly after launch, the spacecraft, the Cygnus's onboard limit detection system flagged an out-of-limit calculated parameter, so it takes a number of different inputs. It does a calculation, and that violated a limit, and it did what it was designed to do, and it canceled the burn. The Northrop team took a close look at all of the individual engine parameters and determined that all of the hardware was actually functioning within acceptable limits. That calculation is a little bit more conservative, and so they reworked the far-field rendezvous plan to keep us on time with our planned arrival time. It was pretty impressive to watch them do that, and of course that was important to us because there's a lot of science and research that has limited time frames that it can handle between launch and arrival. So they did a fantastic job recovering and reworking the plan after that burn issue they had. Yesterday's capture of NG-21 was actually the 50th free flyer capture that we've done on board station. Of course, we used the SSRMS, or Canadarm2, to do that, and that's pretty impressive. The first one was about 15 years ago. It was HTV-1. That was on September 17, 2009, and I'm kind of tickled by that data point because I was the lead flight director for HTV-1, and I remember sitting on console that day, first time we'd ever tried to capture a free-flying vehicle with a robotic arm, and pretty impressive now to think that we've now done 50 of those. And then, as I mentioned, Progress 89P is coming up, and of course that is loaded with a lot of food, propellant, and supplies for the Expedition 71 crew. I want to give a little bit more detail to what Steve talked about with the task orders, and we understand there's been a lot of confusion. We do a lot of work off and on with SpaceX for any number of different scenarios and contingencies, and so they're not specifically new activities for us, but just to give you a little more detail, the task order that was issued to SpaceX in mid-July was developed to support a contingency return capability for Tracy Dyson, similar to what we did with Frank Rubio. If you recall with Frank Rubio, after we had the Soyuz coolant loop leak, we put in place a capability that allowed for a 5-crew return with the Dragon. When we did that, we used the Soyuz seat liner as the cushion on the Dragon cargo pallet for Frank. And what we realized after that is ideally we wouldn't be taking the Soyuz seat liner and moving it. It is vulnerable to damage when you pull it out and you move it around. And so we worked in a solution that uses a foam, just different foam basically for the cushioning, and didn't require us to move the seat liner. So that gives us a lot more flexibility and doesn't put that Soyuz seat liner at risk. So that's the work that we had SpaceX do in mid-July, and that's actually the generic contingency configuration that we plan to use for all of our Soyuz crew members if we ever encountered a Soyuz vehicle issue and needed to use the Dragon. And then as Steve mentioned, we also increased that number to 7 just so that we have a full range of capabilities for future contingencies. We are really fortunate that we've got evolving capabilities in a framework that allows us to put in place alternate crew contingency options. I think the Soyuz coolant leak taught us quite a bit. You know, we'd always been protecting for anomalies on board station, but you know, you can have any number of an anomaly on a crew vehicle too, whether it's a micrometeoroid strike or anything else. So smart for us to always have backup plans in place. Steve mentioned the specific backup plan for Starliner, and just to give you a few other pieces to that plan, if we did fly up Crew 9 with 2 crew, our plan is to leave Butch and Sunny on board to execute the rest of that expedition. They would return on Crew 9 with the normal crew rotation timing. A couple years ago, we made the decision, knowing that this was a test flight, to make sure that we had the right resources, supplies, and training for the crew just in case they needed to be on ISS for whatever reason for a longer period of time. So Butch and Sunny are fully trained. They're capable and current with EVA, with robotics, with all the things we need them to do. Of course, as you know, they have both actually done expeditions on board station previously. They've also done EVAs for us. I did pre-position their EVA gear earlier in the year just to have that on board, so they've got suits that fit them, and so no issue or challenge with them performing the increment if we really had to do that. And to reiterate what Steve said, those are backup contingency plans. We have not made any decisions at all in terms of anchoring to a specific plan. I hope that helps fill in some of the blanks and keeps you guys fully informed with our latest. And with that, I will turn it back over to Leah.
Thank you, Ken, Steve, and Dana, for all that information. Again, thanks to everyone who's tuned in online. We'll move into the question and answer portion of our conversation today. A reminder, press star 1 to raise your hand and be admitted into the queue, and press star 2 to lower it if you've heard your question answered. And as mentioned earlier, I will be turning over this portion of the call to Holly, our operator online. So, Holly, I'll let you take it away.
Thank you. Our first caller is Marcia Dunn with the Associated Press. You may go ahead. Your line is open.
Yes, hi. I'm hoping you can hear me. For Steve, Ken, or both, after so many critical problems, how can NASA have any faith in bringing Butch and Sunny home in the Starliner, no matter how many more tests or patches are done?
Yeah, I'll start, Marcia, and then I'll hand it over to Ken. I think if we step back and look at the two big issues we've been working on orbit, really the helium leaks and the thruster issues, I think, the key attribute really to moving forward for the rest of the flight is to understand how those systems are used for the remainder of the flight and what the demand is on both the helium system, which is primarily the deorbit burn, and also the thrusters, which is the deorbit burn. And so we're really trying to understand the usage of the thrusters for the deorbit burn, and then also really delve into the physics of what's happening. I think if we could replicate the physics in some offline testing to understand why this poppet is heating up and extruding, and then why it's contracting, that would give us additional confidence to move forward, to return Butch and Sunny on this vehicle. That's what the team is really striving to do, to try to look at all the data and see if we can get a good physical explanation of what's happening. And I'll see if Ken has anything to add.
Yeah, I'll just add a little bit more there, Steve. I think your description was really good. Marcia, we try not to just make decisions based on how we feel about something, right? What we try to do is go in and be data-driven, look very closely at what we've got in the way of data and then and analysis, bring in experts, and try to pin down what our risk is. When we started this mission, it was a test mission. We knew that it potentially had a higher risk than a flight on a vehicle that has more experience, more flights on it, right? So we're at the point now where we see additional risk that's in a fairly broad uncertainty band, depending on how much data and how much understanding you have. You might take a different view of where we are in that risk band. But switching off of our primary path of bringing Butch and Sunny home on Starliner causes us to take additional risk in the rest of our mission profile. And so we have to compare all those risks, and we'll weigh all that as we make our final decision.
Our next caller is Gina Sinceri with ABC News. You may go ahead.
I think this is probably for Dana, but How did Butch and Sunny react to this announcement? Are they excited about potentially 6 more months up there, or however many months for Crew 9?
I would say it wasn't an announcement. So Butch and Sunny are aware that we're always looking at contingency plans. I mean, this is a pretty common thing that we do. We've always got backup plans. Of course, they knew, before they flew that they had been fully trained, on board. The ground team has done a great job talking with Butch and Sunny and keeping them included in all of the discussions. In fact, I'll let Steve share, but he's had some recent board meetings where they participated. Butch and Sunny are ready to support, and they trust the ground teams. They're ready to support whatever we need to do. They're great crew members, great astronauts, great at flying Starliner. So I'd say they're prepared for either path that we go down. And let me hand it to Steve to share a little bit more insight with you in terms of communications with Butch and Sunny.
Yeah, I would say, Gina, we continue daily, weekly to update Butch and Sunny. They will, the great news is the station has a lot of capability. They can dial into our meetings. They dialed into our program control board last Tuesday, and we're able to sort of hear all the different various opinions of where we're at and all the data that we've been putting together and all the different risk assessments. So they're getting that data. I think Butch and Sunny are ready to do whatever we need them to do. They could be coming home on Starliner, before September 24th. As Dana said, we haven't made a decision yet, right, of whether we pursue the rest of the mission and complete it nominally, as Ken said, or we have Starliner come home in an uncrewed configuration. So that's a decision ahead of us. Knowing Butch and Sunny, they are professional astronauts and test pilots, and they understand the difficulties of the decisions that we're faced. They have complete confidence in the ground teams, and then they'll do what we need them to do.
Next caller is Jackie Waddles with CNN. You may go ahead.
Hi, everyone. Thanks so much for hopping on. I think I speak for a lot of us when I say I hope that we can get more frequent updates like this. It's been a couple weeks now since we've had updates on Starliner, and also would really love to be able to hear from your Boeing counterparts in situations like this. So for my question, I just want to follow up on some reporting from my colleague Eric Berger. So it sounded like behind the scenes there was some pretty serious concern about if Starliner has certain thrusters fail during undocking, that it could pose a threat to the ISS or become uncontrolled. Can you tell us if that's true, if that's something that's really being discussed behind the scenes? And if so, how big are those concerns? How widespread are those concerns? Thanks so much.
I'll start at a high level, and then I'll let Steve fill you in. So our strategy, we have fault tolerance for any number of things. So we've got sufficient fault tolerance for undocking, so we're not concerned about the, let's say, immediate proximity around ISS. The other thing that we've done in the past with the vehicle, the attitude that we're in when Starliner undocks is I'll call it a passive release attitude. So even if, for example, the vehicle did nothing and just drifted out, it's on a safe trajectory for ISS. That's not the state the vehicle would be in, but that's an added, let's say, layer of conservatism that is already there. And so I'm not sure what the specific concern is that you're referring to, but there is plenty of fault tolerance. Plus, there is safe, complete drift-out trajectory if none of the thrusters were working at all. So, Steve, you want to add anything to that?
Yeah, I would just say, from a thruster perspective, the biggest demand on the thrusters for the remaining portion of the flight is really the deorbit burn. There'll be a few thruster firings to back away from ISS, and then a burn to basically take it over the top of ISS, and then I would say below ISS, and then moves out in front of ISS. Those firings aren't that stressing on the thrusters. Where we get into the next part of the flight, and again, the heating is not nearly what we saw on the day of rendezvous when the thrusters are firing very rapidly, not only to keep Starliner pointed toward the ISS, but also to fly it up the corridor and into the docking area. But But the deorbit burn has a number of firings as the OMAC engines, the orbital maneuvering and thruster control engines, fire for the deorbit burn. 4 of those. The RCS thrusters will fire to hold the orientation of Starliner to make sure it's pointed in the right direction to get all the thrust you need out of the engines, and that's the next stressing case. So it's really the real concern is how many thrusters can we have fail off. We've done a lot of analysis that have shown that you can have significant number of the aft thrusters fail. In fact, you could have 4 failures of the aft thrusters, and we would still have great attitude control during the deorbit burn. And then after the deorbit burn, we need to maneuver to an attitude to separate the crew module and the service module. And then for that SEP sequence, the aft thrusters aren't required at all. Just want to clarify one other thing on the software. The software that's used, whether it be crewed or uncrewed, is the same software. It's the exact same flight software. What would need to be updated is a specific set of mission parameters, we call those mission data loads, to get into the uncrewed configuration. So the software doesn't have to be changed. The trajectory is the same. It really is on the software side, it's just some contingency mission data parameters in the software that if a crew weren't there, the software could then execute the checking and any response needed in close to ISS.
Our next caller is Bill Harwood with CBS News. You may go ahead.
Thank you. I think this is for Steve. Can you clarify what the actual risks are with the return? In other words, what I'm asking is, what's the worst case, given what you know about the health of the OMACs and the past problems with the RCS jets? You just mentioned you could fail off a bunch of them. It sounds like, and please correct me if I'm wrong, that as long as the OMACs fire, you're going to come down, and the crew would survive that. They might not land where they wanted to, or is it worse than that? I don't understand. I understand keeping it stable during the burn, but I'm not understanding what the worst case failure here is that you guys are spending all this time trying to protect against.
Yeah, that's a good question, Bill. I think it's really the worst case would be some integrated failure mechanism between the helium leaks and the RCS thrusters. And so for a nominal deorbit burn, as I talked about, we fire 1 OMAC in each of the 4 doghouses. And then the RCS jets are just there to hold the orientation. And, essentially we could lose a number of jets. It's really the multiple failure cases where if you lost if you had a helium leak in a certain doghouse and that took out the OMAC in that doghouse, then you could end up with some cases that aren't as easily controlled, and that's really the more stressing cases that the team is worried about. And then the team also really does want to understand the physics. Our white sands testing shows some degradation in thrust over time, which would be acceptable. The team also wants to understand the worst-case ramifications of getting the thruster hot. So far, we have seen on the flights, on multiple occasions, we've got the thrusters very hot, but they also want to make sure there's no particular failure mode if the thruster gets too hot that we haven't seen yet. So I think it's more along the lines of looking at the most extreme cases on the thruster that the team's off looking at.
Our next caller is Micah Maidenberg with the Wall Street Journal. You may go ahead.
Thank you. Hi, all. Boeing said last week that data supports flight rationale for using Starliner to take Butch and Sunny back to Earth. I guess, Ken and Steve, just from where you sit, are you personally in agreement with that view from Boeing, or do you prefer one of the contingency plans discussed, or are you still waiting? And just wherever you are on that, could you please explain kind of the magnitude of debate within NASA about using Starliner to return the crew members? Like, how many people, for example, on the program control board are currently opposed to that? Thanks.
Well, why don't I start, Steve, and then you can kind of finish and tell Micah about the PCB. As I mentioned before, I think reasonable people could have different views on which path we should take. I don't think anybody is taking a view that you could prove is wrong or right. What we've got is an uncertainty band, and the Boeing team, because of their experience and their belief in the resilience of their hardware, that would take them to being very confident that the vehicle could bring the crew home, even right now with the uncertainty that we've got. But we've got other folks that are probably a little more conservative. They're worried that we don't know for sure, so they estimate the risk higher, and they would recommend that we avoid coming home because we have another option, right? We could put the crew on a Dragon. So that's part of the discussion that we're having right now. But again, I think both views are reasonable with the uncertainty band that we've got, and so our effort is trying to reduce that uncertainty. Steve, anything you want to throw in there?
No, Ken, I think you said it. I'll throw a couple things in, but you said it really well. It's about the uncertainty in the data. I think Boeing asserted their vehicle was ready to come home on Friday with the blog post they put out. They listed all the testing that was we have accomplished jointly between Boeing and NASA in that blog, which was good. We've done a fair amount of testing. I think it depends on your experience base a little bit as to how you view the risk. Boeing is looking at the risk from the thrusters based on what they've observed more in previous flights, all the way back to, if folks remember, in 2019 OFT-1, we felled off 9 thrusters, I think it was, very early in the flight due to a problem getting the OI burn off and had some severe heating, a number of pulses on that flight. I think Boeing looks at the flight performance on this flight, the flight performance on that flight, and the testing at White Sands and draw some conclusions. I think the NASA community in general would like to understand a little bit more of the root cause and the physics. And then what uncertainty is there relative to the root cause and the physics. I think those are the two different views, different opinions. And, we're trying to work to get a solution for both of those.
Our next question comes from Joey Roulette with Reuters. You may go ahead.
Thanks. Just wanted to follow up on Micah and Bill's question for Steve or Ken. Can you kind of quantify the disagreements that the NASA team is voicing during these meetings or the program control board? Like, what number of dissents or disagreements are you having compared to those who are supporting the data, or in otherwise? And then real quick for Steve, who comes off, or for Dana, who comes off of Crew 9 under the contingency plan? Would that be NASA astronauts or the Roscosmos astronaut? Thanks.
Yeah, I'll address the latter question first and then talk about the disagreements a little bit. We're not really ready to share the data on which crew members. I think we'll do that at the appropriate time, should we employ that option. Relative to the disagreements, I don't want to, I think the best way to characterize it is the way I said it, right? People with various levels of experience look at uncertainty differently. And so the real disagreements are how much uncertainty they view in the data and how much risk level they view relative to Starliner. And now we actually, for the first time, I think ever in human spaceflight, while docked ISS have 2 U.S. vehicles to choose from in some respect, Dragon and Starliner. And so we knew the test flight would be riskier. The Dragon Demo 2 test flight was risky as well when we flew Bob and Doug in May of 2020. Now that we have had the helium leaks on orbit and we've had the thruster fail off, some in the team don't see that level of risk something that we should entertain. And I think that's where we're having the vigorous debates and discussions at the PCB and then at other levels, trying to gather up the rest of the data that maybe will help bring some other piece of data in that helps lower that uncertainty in their characterization of the risk.
Yeah, and just to give you a feel, we don't really count we don't vote, right? We don't go through and do any type of percentage as part of our process. Just one disagreeing voice can be enough, right, to sway the whole team to move a different direction. But I'd say we heard from a lot of folks that had concern, and the decision was not clear. Right, we heard enough voices that the decision was not clear at the program control board.
And our next question comes from Michael Sheets with CNBC. You may go ahead.
Thank you. Appreciate it. Given what Ken said at the beginning of the call and the variety of factors at play, I think 1-hour press briefings that don't even happen once a week aren't quite cutting it, especially when the briefings try to cover multiple topics at once. But I'll stick my questions to Starliner because that's the one I really want an answer on. Now that Crew 9 has been pushed back a month, what are the timeline constraints on making a decision about Starliner's return? Or in other words, how long do you have to make a decision on Starliner's return, and when do you need to make that decision by?
Yeah, we're in the process of laying that data out right now. I mean, we've authorized Boeing to go lay out the plan, not execute, but lay out the plan for what it would be, what would be required to do the uncrewed undock, and that will get a first look at that schedule probably early next week. Remember that the flight control team for Boeing has trained to do the crewed undock with the crewed parameters in the software. And so we want to go make sure before we execute that we would dust that off. And then again, there's some changes for things that are automated responses with an uncrewed version versus the crew. And so we want to go lay all that work out. When we lay that work out, I think we need to probably decide, likely in the middle of August, one path or the other, to go ahead and meet the launch date for Crew 9 on the 24th. Given what Dana said, we really would like to undock Starliner first to free the port up. And then when we do that, we want to lay in some number of landing opportunities for Starliner. The opportunities are about every 4 days. We have opportunities in September starting on the 2nd and the 6th and about every 4 days. So we want to lay those in as well. So roughly mid-August we need to decide. And we're kind of laying out that path this week.
And our next caller is Lauren Grush with Bloomberg. You may go ahead.
Hi. Thank you so much. This is for Steve or Ken, kind of following up on Michael's question. I'm just curious, what does the next few weeks look like for you? How is this decision going to get made? And who ultimately makes the call about how Starliner will come home?
Yeah, you want me to? You go ahead and explain the process there a little bit, Steve, and then I can weigh in.
Yeah, absolutely, Ken. I would love your thoughts. We need to basically follow up from the program control board we had, where we laid out data, but we didn't necessarily poll in a way that led to a conclusion, I would say. We have new data coming in. I failed to mention we have brought in extra propulsion experts from across NASA, from the Jet Propulsion Lab, from the Glenn Research Center, and from the Goddard Space Flight Center as well, to help. They are meeting here this week to see if there's some data that perhaps we have missed. They're working in concert with our commercial crew prop team and Aerojet Rocketdyne. So once we get all that data together, we'll have to come to the program control board, see if we've closed all the actions as well from the previous program control board, then take that to an agency flight readiness review, make a recommendation to Ken, and then depending on how that meeting goes, there could be another step with Jim Free and ultimately the administrator, and I'll see if you have anything to add, Ken.
I think you summarized it really well, Steve. The way it would work is it comes to the flight readiness review. I chair that review. We'll poll everybody, see where we are. I'll state what my position is at that time. If we have dissenting voices out of that meeting, then it can go to to the associate administrator, and if there's a desire to go even further, it can go to the administrator. The administrator, though, it's important to understand that the decision-making authority I have is delegated from the administrator. Same thing with the associate administrator, right? The administrator ultimately takes responsibility and has a very important concern and responsibility for the final decision. So he will be involved.
And our next caller is Chris Davenport with the Washington Post. You may go ahead.
Hi, thanks so much. Quick, can you certify Starliner if it comes back without crew? Is that theoretically possible? And then just a quick follow-up on Bill Harwood's question about the worst-case scenario. Steve, you were talking about understanding the heat generated by the thrusters and understanding the worst-case scenarios. I just wonder if there's any concerns about the heat inside the doghouse, if that could affect the propellant lines or even ignite the propellant. I think you had said something about concerns about the propellant vaporizing, but I wonder if it gets hot enough, if there could be a more adverse effect. Thank you.
Yeah, I'll take the first question relative to certification. We're laying out that data right now. If we had an uncrewed undock and brought Starliner back safely, I think we would look at all that data. There are many things that are the same with or without a crew. We would have to look at the things that are really needed for a crew on board, like how the ecosystem performs with the crew and so forth, and lay that out. Boeing has already moved out on changes to the helium system. We've talked about the seal that is leaking. Remember the P2D2 flange that leaked pre-flight? They've already moved out on a replacement seal. They're already laying in additional testing for the thrusters to make sure that we hit all the corners of the box on the thrusters. They're already looking at various changes to the flight software and the way it flies, such that it doesn't put as much many pulses on the thrusters and cause the additional heating. Relative to the worst case question on igniting the propellants, right now, the propellants are separate from each other, so you would have to get enough heat to actually rupture a line, and so we don't really see that as a concern. What the doghouses are really doing to us is keeping the heat in, and such that sometimes even when we fire an OMAC, we can get heat soaked back over from that OMAC into the RCS thruster. So we don't really see it as a ignition risk or a concern of combustion inside the doghouse. It really is more about will the thrusters fail off during the deorbit burn or some other time.
And our next caller is Kenneth Chang with the New York Times. You may go ahead.
Hi, thank you. This is with Steve Stitch. Basically, what changed and when and why? I asked you back on July 10th whether there were any contingency plans for Dragon, and you said, quote, certainly we've dusted off a few of those things to look at relative to Starliner just to be prepared. What you described today goes way beyond that. Was that July answer accurate, or when did you decide to actually get these extended plans started? Thank you.
Yeah, I think I'd have to go back and look at the timing. We started in early July doing some early planning with SpaceX for some of these contingencies. Then as we got closer and a little bit more data, we started to put a few more things in place on Dragon. We have this contingency option that we've been working a little bit more in the background for a while. In the last few weeks, we have decided to make sure we have that capability there. As our community, I would say, got more and more uncomfortable with the uncertainty in the thrusters, I think that, to me, upped the priority in having this capability in place. And really, what we have done is totally reversible. We can fly a Crew 9 as planned, as we've been planning for years with 4 crew members, and we can plan to fly it with 2 crew members. And so as we got further and further into it and heard more from the team and the uncertainty that Ken talked about and I've talked about, we decided to put a little bit more effort on that, on getting the Crew Dragon on Crew 9 configured to support the option. So.
Our next caller is Irene Klopp with Aviation Week. You may go ahead.
Thanks. Steve, did folks get less comfortable with flying Butch and Sunny on Starliner following the discovery of the Teflon seal degradation during the White Sands tests, or what is it that actually had the sort of the public-facing view go from Starline's safe to come home at any time, that there's a landing opportunity, we just want more data, to where we are today with all the contingency plans?
Yeah, those are good questions. I would say that testing at White Sands and the discovery, really, that the poppet Teflon was extruding after the testing was a bit of a surprise to us. And so that I would say up the level of discomfort and total, not total understanding of the physics and what's happening. I would think that was a key change. And then, you would think that the thrusters recovering would be a positive thing in that, and I think I misspoke earlier. I think I said July 11th, but that thruster test was on the 27th of July, just a few Saturdays ago. They all seem to recover that Saturday, so that has given the team a little bit of, given what we saw at White Sands with the poppet, given that they've recovered, how are those two things congruent with each other, and then how do we understand the total risk level? And that's what we have embarked upon this week with not only our prop experts, with experts from across the agency to make sure we're not missing something.
And our next caller is Eric Berger with ARS Technica. You may go ahead.
Hi, thanks very much. I just want to echo what Jackie said about transparency. Sox, back in your day, there were 2 briefings a day during shuttle missions oftentimes, and it's been almost 2 weeks since we've heard about this stuff. Steve, I would love for you to talk a little bit more about the software configuration that needs to be changed on Starliner to undock autonomously. I've heard this is going to take several weeks to resolve, and so I'd just like to understand sort of why it might take that long if it's a simple change as you described. Also, can you or Sox give an estimate on the likelihood of Dragon versus Starliner return for Butch or Sunny? I know there's uncertainty, but is it like 50-50 at this point in your mind, or are you leaning one way or the other? Thank you.
I'll take the first question, and then we'll let Ken take the second question. So, yeah, we probably don't explain software very well, and I apologize for that. The software changes really are going back to what I would say would be the OFT2 configuration. And if you just think about the Starliner team, they have moved from May of 2022 into flying a crewed mission. They made a shift, modified the software to have all the capabilities that the crew needs. Essentially what we're asking them to do is go back 2 years in time and resurrect the software parameters that are required to be updated to give the automatic responses to breakouts near the ISS should we have a problem in close to ISS, which now the software allows them to do manually. The team is always updating these mission data loads as the beta angle changes, as different things change, as landing site strategies change. They're always updating these parameters all the way through the flight. So what we really want them to do is, and as Dana mentioned, there's a slight change in the orientation of ISS at undock. So before we employ this methodology of undocking without a crew, we want to make sure we do all their work to make sure it's all tested and correct. We haven't done, I would say, any work since really May of 2022 when we had OFT2 on the uncrewed config. We've had the Boeing and NASA teams focus solely on working toward returning Starliner in a crewed configuration. Before we go execute that, it's just smart and responsible to go take the software and the mission data loads in this configuration, go into the integrated test facility. We call it ASIL, which is where all the flight software resides, all the flight hardware associated with the avionics resides, and then go run it through some test cases just to make sure we haven't missed anything. That's really what we would go do. That's really what would take the time if we were to pivot if we were to pivot to an uncrewed undock, that's what we would go spend our time on. And I'll let Ken answer the second question.
Yeah, Eric, thanks for the thoughts on the press conferences. I appreciate that, and really appreciate your interest and how hard you're working to get accurate information out there to everybody. To give you a number, it's just really hard right now. I can't give you one. It could change drastically one way or another depending on new data. But I would say that our chances of an uncrewed Starliner return have increased a little bit based on where things have gone over the last week or two, and that's why we're looking more closely at that option to make sure that we can handle it. But again, new data coming in, new analysis, different discussion, we could find ourselves shifting another way.
And our next caller is Anthony Leone with Spectrum News. You may go ahead.
Hello. Thank you so much for taking our questions today. It's a shame that Mark Nappy isn't there. I'm sure I'm not the only one who has a few questions for him. My question is this. Going forward, what is the future of Starliner, and will NASA change some of its recommendations of testing spacecraft before a crew can actually board on there? Thank you.
Yeah, I think the path forward for Starliner is to complete the rest of the test flight to undock. I would like it to undock with the crew, but if we don't end up getting there with the entire community, undock, execute the deorbit burn, return home, and then make the corrections to the problems that we've found. These problems can be fixed. The helium leak, it's maybe changing out this seal that we talked about and looking at that system and changing maybe the way that system's put together. And then the thrusters, doing a little bit more testing at White Sands and then figuring out how to fire them less. So I see a bright future for Starliner. Either way, we really need two crew transportation systems. There could be a day in the future where we're calling upon Starliner to do something for us like this. And it's a great vehicle. It's got great capability. And, Boeing has done a tremendous job working on it in concert with commercial crew. And so I really see that there's a viable path for Starliner either way that we go. In terms of testing vehicles or changing the way the requirement to have this uncrewed test flight and then a crewed test flight, I think so far that's worked well for us. I think the one area that we probably had a miss in is the doghouses and the thermal effect in the doghouses and what effects that caused on the thruster, that it's not easily tested on the ground. It's not easily analyzed. It's not easy to put the whole doghouse and service module in a chamber and fire the thrusters. And so that's probably the one thing that we probably need to think about a little bit more. Is there something that we could do differently there to make sure we didn't have these kinds of problems in flight?
And our next caller is Tim Fernholz with Payload Space. You may go ahead.
Thank you for taking my question. Always good to get an opportunity to talk with you folks about this. I just want to make sure for Ken and Steve that I understand the situation. Right now we're hoping to get a root cause for the issues with the propulsion system before a decision is made on which vehicle the astronauts will return on. And we're going to do that by mid-August, and we're going to do that by analyzing the existing data and bringing in new propulsion experts from across NASA, but we don't anticipate any new testing. Is that right? And just a quick second thing, what's the story with the water intrusion on the Falcon 9 for Crew 9? Thank you.
Yeah, let me see if I can take the first question. We have brought in extra experts, and we are trying to do some tests on the ground. We've got a couple theories about how to test this Teflon. We don't have a lot of data at high temperatures, and so how it performs at high temperatures and cooler temperatures. So that's something we're off working on. Can we come up with a test to do that? There may be other tests that we determine are necessary in the near term that we may embark upon. And then we're building a model also of the Teflon to see as you It's called a finite element model. You break the Teflon up into little pieces, and you expose that model to the thermal and forces that it sees, and then try to understand how that material swells over time when exposed to temperature. So we're doing that work as well. Relative to Falcon 9 first stage water intrusion, there was some moisture that went into the fuel in the LOX tank of that booster when it was transported from McGregor to the Cape. The desiccant system didn't perform the way it was supposed to. That desiccant system is supposed to keep that air dry, and so it didn't perform the way it was supposed to, so we had to dry those tanks out and then replace a few components on the vehicle. And so getting a shakedown flight of that on a Starlink would be helpful for us. That's just kind of a side benefit of moving from August to September.
And our next caller is Will Robinson-Smith with Spaceflight Now. You may go ahead.
Hi, thanks for taking the time. Question to either Steve or Ken. Given what is now known about Starliner and the testing and analysis that is still yet ahead, if there were a contingency scenario where an emergency were to happen on station, does NASA still feel like Starliner is a safe vehicle for Butch and Sunny to return on now if it were needed to be called upon today? And then just a quick second follow-up to Steve. Can you update us on the status of the second stage analysis for the Crew flight test, or for the Crew 9 flight? Thanks.
Let's see, relative to the first question on the contingency return capability, we still agree that the right course of action would be to return Butch and Sunny in Starliner. Should there be an emergency at ISS where it's an uninhabitable environment or they need to get off station, Starliner would be their best option, and we still feel confident in that. Relative to the second question, we have been following along with the FAA's investigation on the second stage anomaly on the Merlin vacuum engine, what we call the MVAC engine. Our second stage has been through testing at McGregor with the modifications that we spoke of on the press event. I think that press event was on the 26th, or maybe it was the 19th of July. So it's been through the stage testing at McGregor. We removed that sense line, removed the transducer from the vehicle, tested that vehicle. The testing all went well. SpaceX has flown now, I'm probably losing track, at least 3 or 4 Starlinks, plus the NG-21 flight with the modification. Our team's feeling pretty good about that. We swapped out the turbine housing, and we're working through that swap out, and that's coming to the program control board Thursday, which is tomorrow. So that's the latest status on the second stage on Crew 9.
Yeah, well, this is Ken. It may be confusing folks that we're willing to put the crew on for a contingency return, but still talking about the planned return. And part of that is how we make decisions about risk in contingency situations. It's pretty unlikely to get into one of those contingency situations, number one. And then number two, because of the criticality of those situations, we typically would be willing to accept a little more risk. So that's how you get this apparent difference in what we would be willing to do in the different situations.
Our next caller is Isam Ahmed with AFP. You may go ahead.
Yeah, hi. Thanks for doing this. I was just wondering, given the sort of fundamental flaws that have been uncovered in this sort of design process, what does that mean for the future of the certification process? If Butch and Sunny do come home on the Starliner, will it certainly be certified, or could there be a possibility of more work needs to be done? And we can see that Boeing has some blame here, but does NASA also share some blame in failing to oversee them adequately and allowing these design flaws to go unnoticed?
Yeah, obviously the certification process isn't really just about landing, and then if the landing goes well, that vehicle is certified. We have a whole process of certification that we needed to go through relative to the data that's obtained from this flight. We obtain pressure data that's recorded on board. We'll go look at all that data. And then there's a number of changes that Boeing will be rolling in for Starliner 1 that we've talked about. I think we mentioned in the area where the landing loads are the highest, called an airbag backing panel. It's where the airbag's essentially attached to the structure of Starliner. That's going to be modified, and we have to go through certification on that. I think we've talked about the suits and seats are going to have some modifications. Obviously, the flight software has modifications to go to both the forward port and the zenith port, so there's many modifications that have to be certified. The changes to the dog houses relative to helium would undergo certification as well, and that data would be given to NASA along with whatever the changes to the way the vehicle flies to reduce the demand on the thrusters in terms of the heating. Relative to the certification process and how we got here in flight, I think we'll have to go back and look at that. We see things on every flight that are a bit of a struggle for engineers to explain why did we miss that. We had that in Space Shuttle. I remember a flight, STS-95, where that many flights into the program, the drag chute door, when the engine started at liftoff, the drag chute door fell off, contacted the engine, and then we had to go work in the flight. Was the drag chute safe to deploy, or were we worried about it coming out? So that, you could say, was a certification miss. Obviously, Orion is dealing with, what they learned on the heat shield from their test flight as well, Artemis 1. It's every test flight, every time we fly, we learn something new. SpaceX, after 300 Falcon 9 flights, found when they made a very simple design change, removed a bracket and changed a transducer on the Starlink flight that had the MBEC anomaly, ended up having a failure of the engine. So I think it's really tough, this business is. I always do a bunch of soul searching afterwards, like what did we miss, and we'll do that, and we'll see if there's anything we can improve in our processes.
Our next caller is Elizabeth Howell with Space.com. You may go ahead.
Thanks, everyone, for your time. This might be for Dana. Can you clarify, if possible, who would be flying on Crew 9 if it was only 2 astronauts? Would it be the pilot and the commander, for example? And I'm also wondering about the implications for future missions. If it was only 2 going up, would that affect the composition for Crew 10, for Crew 11, and the alliances with other space agencies such as Roscosmos? Thanks very much.
All right, let's see. Just to echo what Steve said, we're not ready to share specific crew names for the contingency plan. If we find ourselves in a position where we do make a decision that we're not going to fly Starliner back with Butch and Shunny, we'll share those details at that time. But more generically, sending up 2 and then having Butch and Sunny stay on board, just to kind of walk through that. So they stay on board and they end up doing the full increment. Crew 8 comes home with a normal Crew 8. And then at that point in time, we're back into our normal rotation plan. So there are no other deltas or changes. It's just a specific change to Crew 9 dropping down to 2 crew.
And our next caller is Jeff Faust with Space News. You may go ahead.
Thank you. And then I'll ask my colleagues who want this to be the first of a more frequent series of briefings during this dynamic time on station. For Steve, are there particular data sets or analyses that you are counting on to make a decision on whether to have Starliner return with the crew or not? For example, do you need to understand the physics of what's going on in the thruster with the seals expanding and the propellant vaporizing before you would approve having a crew come back on Starliner? Thanks.
Yeah, I think the team would like us to understand that physics a little bit better to try to answer the understanding of this, why this Teflon is swelling, and then why is it likely that it basically restored itself back to a normal configuration such that the flow return so that we get nominal thrust, which we saw when we did that docked hot fire on the 27th of July. So that's some key data. And then anything that we can do with thruster experts or testing to understand the potential uncertainties and to make sure that there's no way that there's a real serious catastrophic failure mode of the thruster. So far, what we've heard from Aerojet and experts is that's not true, but we're making sure we do our due diligence to understand if there's a potential failure mode that where the thruster could have a leak or something like that. So far, we haven't seen that, but that's really the data that we're taking our time to go through that data.
Next caller is Marina Corin with The Atlantic. You may go ahead.
Hi, a question for Steve. In your discussions with SpaceX, have you considered organizing an entirely new Dragon flight to bring Butch and Sunny home so that they don't have to remain on station until February 2025? And a quick one for Ken. My colleagues on this call have already said that we would have really liked to hear from someone at Boeing today, but I do want to ask, why isn't Mark or another Boeing representative on the call today? And given the amount of work that you've done with SpaceX to prepare for the contingency plans you're telling us about today, why isn't a SpaceX representative on this call? Thanks.
Yeah, I'll let Ken.
Why don't I do the last one first, Steve, and then you can go, huh?
Sure.
Today we wanted to just kind of give you the NASA team's point of view on all the complicated issues on ISS. We'll have chances to bring Boeing back along with SpaceX in the future as we progress. Today I really wanted those guys to be able to work on the technical issues rather than being here at the press conference, but we'll give them an opportunity in the future. Steve, go ahead.
Yeah. The relative to sending up a new Dragon so that Butch and Sunny didn't have to stay up till February, we really never considered that option from the very beginning. We liked the option of modifying Crew 9 or Crew 8. We looked at both of those and bringing them back in either one of those vehicles. We're trying to lay out the rest of our manifest, to make sure we have vehicles available for all the flights. It just didn't make sense to go ahead and accelerate a flight with SpaceX to return Butch and Sunny earlier.
Our next caller is Clayton Sandell with Scripps News. You may go ahead.
Yeah, thanks. One of my questions just got answered, but I will ask, we haven't heard from Butch or Sunny since July 10th, and I was hoping you might commit to having them participate in another on-orbit press conference as soon as one can be scheduled. Thanks.
Our plan is once we make the decision, and hopefully, as Steve said, that's mid-August, we're planning onboard station to set up a press conference with Butch and Sunny. So that'll be coming around the corner when we have our decision made.
And our next caller is Stephen Young with Spaceflight Now. You may go ahead.
Thank you. I have a question on the timing and sequencing. You're going to have to depart the Crew 8 Dragon and Starliner and dock Crew 9. How is that all going to work? What is going to be the lifeboat plan for Butch and Sunny if Starliner goes first? And you also did an inspection of Starliner with the robot arm after the hot fire test. I'm wondering why that was performed and what you might have learned during that.
Yeah, I'll take the last question first. We did an inspection. I believe it was on July 30th of the vehicle. We did a standard MMOD survey, lining us up for the next set of undock opportunities. That's good for a number of days. I have to go back and check on how many days that's good for. So it's just an opportunity to take a look at the vehicle and see if there was any MMOD damage at all. Relative to the sequence that we're talking about, so the first event in the sequence is Starliner has to undock first. That would free up the forward port on the space station. Then, right now, that would happen first. And then after that, we will do a port relocation to move. Once we launch Crew 9 we'll launch Crew 9 next. That will be the next launch. We'll dock to the forward port, the forward IDA. After that vehicle docks, then we would have Crew 8 undock and return. And then before the cargo flight, we want to relocate the Crew 9 Dragon from the forward port to the zenith port because the next vehicle, we would like it on the forward port to do some demonstration. And I'll let Dana talk about that.
Let me just add one thing in the sequence. You specifically used the word lifeboat and talking about Starliner going first. So before we would undock Starliner, Steve mentioned previously we were putting in place work for the Dragon crewed vehicle to have up to 7 people. So basically you can do 5, 6, or 7. It covers all different crew configurations. The first step would be if we were doing an uncrewed Starliner undocking, we would first configure the Crew 8 Dragon vehicle to be able to handle the 2 additional crew members. So we would put a contingency configuration in place first to make sure we have a contingency return vehicle ready. Then we would undock Starliner. Then we would launch Crew 9, launch Crew 8, do the handover. Crew 8 will leave. Then, as Steve said, we would relocate Crew 9 to get ready for our cargo mission. So that's how we would handle the lifeboat configuration for the uncrewed undock scenario.
And thanks, Dana. I feel for reporters that have to understand that whole thing, because as we talk it's very complicated. So,
our next caller is Ryan Caton with NSF. You may go ahead.
Hi, thanks very much. Very quickly, I will also echo the comments earlier. More frequent conferences and transparency is really, we really desire that. I understand you do not want to name the astronauts right now, but in the event that 2 up, 4 down Crew 9 contingency is activated, do you know when those 2 astronauts which are bumped off Crew 9 would fly? Will 2 astronauts on every future Dragon mission now be bumped one flight further down the line, or how's that going to work out? Thanks.
We haven't worked through those specific details. We tend to assign crew in general a couple years out to get them into training. But in this particular case, we've got crew members who are already proficient and trained, so our flexibility is much higher in this particular case. They're fully qualified to go fly on ISS, do all the ISS work, they're fully qualified for Dragon. So if we found ourselves in that situation, that's something we'd do, is we'd go look at future manifests and just see what makes sense for the overall crew complements going forward.
And our next caller is Anthony Colangelo with Marine Engine Cutoff. You may go ahead.
Hey there, thanks. If the decision were made to send Starliner out uncrewed, is there additional testing that you would do on the way back before reentry, or would you fly it exactly as if the crew was on board for the certification stuff that you talked about earlier? Thanks.
Very good question. The one thing that we're thinking about or talking about what to do with is the additional hot fires once we undock. Should we hot fire all the thrusters again to understand their performance, or there's this one thruster that had severely degraded thrust on docking day, B1A3. Should we hot fire that thruster? That's really the main thing that we've been talking about doing relative to the undock SEP sequence and the deorbit burn.
Our next caller is Manuel Mazzanti with Exploración Espacial. You may go ahead.
Thank you very much, Manuel Mazzanti, Exploración Espacial. A question for Dana, following previous comments. I know that you cannot mention names so far, but in the case that this contingency plan moves forward, launching Crew 9 with 2 members, what would be the rationale? Would it be based on the activities they need to perform, like science-based, prioritizing science, EVA, maintenance, international partners? And a quick second question, have you ever considered modifying Crew 9 in some way that you can return with 6 astronauts, like the original Crew 9 plus Butch and Sunny, given the fact that Crew Dragon could handle 7 astronauts, I guess? Thank you.
All right, I'll take that first one, and then I'll let Steve talk about the second one. There are a lot of things that we take into consideration when you look at crew complements, and in a case like this, specifically looking at Butch and Sunny's training and the rest of the crew complement and what makes sense both for ISS, but also specifically for the Dragon. The Crew 9 crew trained together with 4 crew. Though in this case, we have this contingency. They fly up with 2, so we're looking at all of those factors combined to make sure that we make the right decision. And I'll let Steve answer the second one.
Yeah, relative to additional capability beyond the 4 seats we have in Dragon, SpaceX had some of those concepts early on relative to additional astronauts. Right now, the seats have to rotate during entry, so it would be really difficult on the cargo pallet to install more seats. And, of course, then we would have to modify the Eclipse system to handle flow to those suits for cooling and then also for air and then O2. So, we talked about it a little bit over the years, but we really don't have the time to implement such a system. And so we feel like we've gotten the best solution now, which would be to fly 2 up and then 4 back on Crew 9, should we need to employ this option.
And our next caller is Gina Sunseri with ABC News. You may go ahead.
Yes, is this the only major problem you see that causes you to have, with the RCS thrusters, that causes you to have call coming back on Dragon an alternative?
Yeah, really, it's the thrusters and combined with the helium leak. I talked about, if you had a helium leak that was so big that you couldn't, you isolated it and couldn't then repress a doghouse, that would be these 2 things, the helium leaks and really the thrusters are the 2 things that working together would give us concern relative to executing the remainder of the nominal mission, bringing Butch and Sunny back on Starliner.
Our next caller is Megan Bartels with Scientific American. You may go ahead.
Hi there. Can you hear me okay? Hello? Can you hear me okay?
We have you.
Oh, great. Thank you. I just wanted to echo everyone else's calls for having more regular press conferences and also for giving us access to Boeing and SpaceX representatives to talk about these issues. I did want to ask, I'm not sure who this would be, maybe for Dana, but if the Crew 9 contingency plan does fly, you mentioned, or someone mentioned, sending up 2 crew members and having ballast for the other 2 to replace the other 2 crew members. Can you talk about why it would be ballast and not like supplies for the space station, non-consumable material kind of thing?
Yeah, that's a good question. Really, what we're looking to do is replace the weight or the mass of a crew member in that seat, and so we can fly up some supplies, some additional foam in that seat, but there really is a metallic ballast config that SpaceX has built and would fly up in the seat just to make sure the center of gravity is unchanged. All these capsules have a pretty tight center of gravity, and the ballast would have to be flown in the seats on Dragon for that purpose.
And that is all we have time for today. Thank you all again for tuning in, and thank you for your questions. Thank you again to Ken, Steve, and Dana for participating and sharing the latest updates with us. We will continue to provide updates at blogs.nasa.gov/commercial crew, and that will do it for us today. So thank you all again for joining.